Till now, we completed 3 chapters in second PUC. Chapter number 1 is matrices. Chapter number 2 is determinants. Chapter number 3 is relations and functions. Right? So, fourth chapter, that is differentiation. Regarding this differentiation, in first PUC we already learned little bit. We learned derivative formulas by using first principle. See, here I am going to revise those first PUC formulas quickly. This class is all about learning derivative formulas. You observe here dy dx of k equal to 0. Here k represents constant. Derivative of constant, d means derivative. Here k is constant. Derivative of constant with respect to x is 0. So you need to remember this formula. What is this? Dy dx of constant equal to 0. For example, while doing problems, you saw like this. D by dx of 1 by 2 is there. As 1 by 2 is constant, its derivative is 0. D by dx of minus 1. As minus 1 is constant, derivative of constant is 0. Here, d by dx means derivative with respect to x. Okay, so you learn first formula. Derivative of constant is 0. Now you see, derivative of e power x is e power x. It is the easiest formula. Derivative of e power x is e power x. Here d represents derivative, dx represents we are differentiating with respect to x. Why I am specifying this notation is new to you. Dy dx means derivative with respect to x, right? So dy dx of e power x means what? Derivative of e power x with respect to x. So you learn two formulas. Derivative of constant is 0. Derivative of e power x is e power x. Very easy to memorize. See, differentiation is all about formulas. In this class, we are going to learn total 23 formulas. You need to memorize these 23 formulas. In every problem, we will use these formulas in this differentiation chapter. Okay, e power x is over. Now you see a power x. What is this dy dx of a power x? It means derivative of a power x with respect to x. Derivative of a power x is a power x into log a base e. To memorize this, derivative of a power x starts with a power x only. A power x into log a base e. So derivative of a power x is what? A power x into log a base e. So you learn three formulas. First one, derivative of constant is 0. Second one, derivative of e power x is e power x. Third one, derivative of a power x is a power x into log a base e. Now you see these next three formulas. D by dx of x power n, that means derivative of x power n with respect to x is n into x power n minus 1. N into x power n minus 1. By using this, we can calculate this type of thing. Suppose derivative of x cube is there. What is derivative of x cube? 3 into x power 3 minus 1 is 2. So derivative of x cube is 3x square. Similarly, derivative of x power 4. Derivative of x power 4 is 4 into x power 4 minus 1. So derivative of x power 4 is 4x cube. So derivative of x power n is n into x power n minus 1. Okay, you need to memorize these formulas. Derivative of 1 by x power n. Here, this formula I got from this only. 1 by x power n is nothing but x power minus n. Okay, so here I written this formula separately so that we can use this directly. I am getting this from this formula only. Derivative of 1 by x power n is minus n divided by x power n plus 1. Derivative of 1 by x power n is minus n divided by x power n plus 1. For example, derivative of 1 by x cube is there. Derivative of 1 by x cube is what? Minus 3 divided by x power 3 plus 1, 4. So, like that, we'll apply this formula. You need to memorize this. Okay. Derivative of log x base e. Derivative of log x base e is 1 by x. So total 6 formulas we have related to derivatives of algebraic functions. See, these are all algebraic functions. Derivatives of algebraic functions. You note down these formulas, be thorough with all these formulas. These are very, very important formulas. This weekend on Friday, I'll conduct a meeting on this differentiation formulas. So I'll ask all derivative formulas on Friday. So please be good in these derivative formulas. Total 23 formulas are there. Now we completed 6 formulas. Okay. Now we'll move to next set. See here, derivative of sin x. Derivative of sin x is cos x. Derivative of sin x is cos x. Derivative of sin x is cos x. How do you know derivative of sin x is cos x? In first PUC, 3 important questions we did. Find the derivative of sin x by using first principle. There we proved derivative of sin x is cos x. So we will take it as a formula. D by dx of sin x means derivative of sin x with respect to x is cos x. So derivative of cos x is minus sin x. Derivative of cos x is minus sin x. Derivative of tan x is secant square x. So these 3 formulas you need to memorize. Derivative of sin x is cos x. Derivative of cos x is minus sin x. Derivative of tan x is secant square x. Now we will see next 3 formulas in this. Derivative of cot x. Derivative of cot x is minus cosecant square x. Derivative of secant x. Derivative of secant x is secant x into tan x. Derivative of cosecant x. Derivative of cosecant x is minus cosecant x into cot x. You need to memorize all these formulas. Here, I'll tell you one trick here. See, whenever trigonometric function starts with c, its answer starts with minus. You observe. D by dx of cos x. Whenever trigonometric function starts with c, its answer starts with minus. You observe here. Whenever trigonometric function starts with c, its answer starts with minus. See here, cosecant x, it starts with c, its answer starts with minus. So it is important, these formulas, see, differentiation is all about formulas. I'm specifically saying in every problem we are going to use the formulas. If you know all these formulas, you are the king in this chapter. If you do not know the formulas, you are nothing in this chapter. Like that, these formulas are that much important. Take pen, paper, write all these formulas, learn these formulas today only. Right? So derivative of sin x is cos x, derivative of cos x is minus sin x, derivative of tan x is secant square x, derivative of cot x is minus cosecant square x, derivative of secant x is secant x into tan x, derivative of cosecant x is minus cosecant x into cot x. How do you know all these formulas? In first PUC, by using first principle of derivative, we proved all these results. I am just revising all those things. However, if you want, you can prove all these things now also, right? Now, derivatives of algebraic functions over, derivatives of trigonometric functions is over. See, derivatives of inverse trigonometric functions. In the differentiation after third exercise, I am going to prove these results. Why derivative of sin inverse x is this, why derivative of cos inverse x, all those things I am going to prove. But I want to write all the formulas at one place. That's why you please go through these formulas. After the third exercise, I will do the proofs of all these things. Derivative of sin inverse x. Here, this is sin inverse x. There is a chapter called inverse trigonometric functions. There we will learn sin inverse x. Derivative of sin inverse x is 1 divided by square root of 1 minus x square. Derivative of cos inverse x is minus 1 divided by square root of 1 minus x square. You see these two formulas. If you learn this is very easy. Only the difference here, minus only. Derivative of sin inverse x is 1 divided by square root of 1 minus x square. Derivative of cos inverse x is minus 1 divided by square root of 1 minus x square. Now you see this tan inverse x and cot inverse x. Derivative of tan inverse x is 1 divided by 1 plus x square. Derivative of cot inverse x is minus 1 divided by 1 plus x square. Derivative of tan inverse x is 1 divided by 1 plus x square. Derivative of cot inverse x is minus 1 divided by 1 plus x square. You observe these two things. What is the difference? Minus is the difference. So if you learn this, then you can write it very easily. Derivative of tan inverse x is 1 by 1 plus x square. Derivative of cot inverse x is minus 1 divided by 1 plus x square. Now derivative of secant inverse of x. Derivative of secant inverse x is 1 divided by x into square root of x square minus 1. Derivative of cosecant inverse x is minus 1 divided by x into square root of x square minus 1. What is the difference between these two? Only minus is the difference. So if you know derivative of secant inverse x, you can easily write derivative of cosecant inverse x. So take pen paper, write all these formulas. Till now what we learned? We learned derivatives of algebraic functions, we learned derivatives of trigonometric functions, we learned derivatives of inverse trigonometric functions. Now we will see some basic rules of differentiation. See, dy dx of ku. Here k is constant, u is some function. Dy dx of ku is k into derivative of u. By this time in physics you already used all these things, right? Dy dx of ku is k into derivative of u. Dy dx of u plus v, derivative of u plus v. Here u is one function, v is another function. Derivative of u plus v is derivative of u plus derivative of v. Derivative of u minus v. Derivative of u minus v is derivative of u minus derivative of v. So here these three are the basic formulas. Dy dx of ku is k into derivative of u. Dy dx of u plus v is derivative of u plus derivative of v. Derivative of u minus v is derivative of u minus derivative of v. While doing basic differentiation problems in next class, I will explain these things more clearly. For time being, you just take these as basic rules of differentiation. In next class, I will give clear examples. Next class is about basic differentiation. There I will discuss about these basic rules. Now you see, you already very familiar with these two formulas. In first PUC, we used these things. This is UV, product rule. This is known as product rule. Derivative of UV is, here u is a function, v is a function, product of two functions derivative. Derivative of uv is u into derivative of v plus v into derivative of u. Product rule, u into derivative of v plus v into derivative of u. Okay, you already learned this in first PUC, just revising. Derivative of u by v, this is known as quotient rule. Derivative of u by v starts with v. Derivative of u by v starts with v. V into derivative of u minus u into derivative of v divided by v square. So derivative of u by v is what? V into derivative of u minus u into derivative of v divided by v square. So throughout this chapter only 23 formulas are there. So these 23 formulas we will use very frequently. With these 23 formulas, if you are very good in trigonometry formulas, those things also going to help you a lot in this differentiation chapter, right? So please take pen paper, write all the formulas. These formulas plays very important role in this differentiation chapter. As I am saying, on Friday I will speak with each and every student and I'll ask the formulas related to derivatives. Please go through all these formulas. These are very important formulas. Take pen paper, write all the formulas, practice, do formulas puja every day, derivative formulas puja every day. These are that much important. Please learn these formulas without fail.